Here we have a statistics question regarding brand name recognition, and it's about a coffee shop whose recognition rate is 54%. And someone from the company meets 6 random people, and the question is about the probability that the number that recognizes the name is not 4. And also, it's asking for the mean value of the given probability distribution. This word not is going to confuse some people, so in the beginning we will assume, or we will find the number to be 4. We'll find the probability for the number to be 4, and then think about not later, okay? All right, so the most important thing in this question is to first recognize that there's this probability of recognition, which is p equals to 0.54. And moreover, this probability is about one person recognizing, right? And this is being repeated for 6 people. And if probability is repeated over and over again, that's called the binomial distribution, right? So for binomial distribution, you need to get the value of q, which is the probability that p wouldn't happen, so it's 1 minus p. And because 6 people are chosen and each person could or could not recognize the brand, so this probability 0.54 is repeated 6 times, and therefore that's binomial distribution, okay? And once you know that it's a binomial distribution, everything else just follows, because you just know which formula to use and what calculation to do. So this is probably the hardest part, recognizing that this question is about binomial distribution. Okay, let's carry on. So the formula for the probability where x is equal to k, in our case, x is the number of people who recognize the brand out of the 6 people, and we're looking for the probability when k is 4, when 4 people recognizes the brand. So we use this formula, this n choose k. N choose k is computed as n factorial over k factorial n minus k factorial, where factorial means you multiply 1, 2, 3, 4 up till n. And then I plug in p and q values with k equals to 4 to get this value 0.2699. Now, it's really hard to do it without a calculator, so of course you're going to use the calculator for this. And if you have a scientific calculator or graphing calculator, on your calculator you can use the NCR function to calculate n choose k, because this is another symbol for the same thing. So you can do 6 choose 4 to calculate this value, and then the rest you can just calculate separately. Moreover, if you have a TI-84 or TI-83, the easier way to do this would be just to use the probability distribution function. You can access it by doing second vars, then you get all kinds of probability distribution. You have to scroll down to find the binom PDF and set the number of trials, because it's repeated 6 times. Trials is 6, individual probability is 0.54, and you're looking for the success of 4 people recognizing, and you just put these numbers and then enter, you'll get the value to 0.2699 something. On the other hand, if you have a TI-83, it's pretty much the same thing, but you have to remember which values to put in. So the order is trial, p, and x. It's npx. You have to remember this value. If you put it in some other order, it will give you some unmeaningful number. So that's the downside of having a TI-83, but you will have to remember it. So npx, okay? All right, so once you have that, now we are going to be concerned about this not. When you have a question about finding the probability of something not happening, you just have to subtract from 1. So since the probability of x equals to 4 is 0.2699, probability of x not being 4 is 1 minus 0.2690, which is 0.7301, or 73% chance. And then we can move on to the second question. So being a binomial distribution, it comes with 2 very important formulas: the mean value, or the expectation value, which is n times p. So mean value is same thing as expectation value in a probability distribution. So sometimes it's written as mu, or sometimes it's also used as expectation value of x, or E of x. And the standard deviation is written as sigma equals to, the formula for that is square root of NPQ. Both of these formulas are very important. You have to memorize them. And to get the expectation value, you just simply multiply 6 times 0.54, which is 3.24, which means that it's the most probable number of people recognizing it out of the 6 would be about 3, because this rounds to 3. Okay? So if you actually calculated the probability for 0, 1, 2, 3, 4, 5, 6, all the possible cases, you'll see that 3 has the highest probability.